Hey guys, welcome back. We're going to do some more power rule examples, okay? Oh no. Okay. This problem here, I can't use the power rule. The power rule only applies to single terms that are separated by pluses and minuses. This has a division. You could never in your entire life, well, you could, but not until section 2.4. You could never in your entire life take the derivative of a quotient, okay? So I know what you're gonna do. You're gonna say, hey, that's a monomial in the denominator. Can't I just write it out like this? And I'm gonna say, great job, all right? Then you're gonna reduce them because you could never do the derivative of a quotient. You could, but you can't do it now. Okay, what about this guy here? That's a 1 there. I can bring anybody up as a negative. Now it looks like a power rule. You guys ready? All right, let's do this. 3, recopy, bring it down by 1. 1 times 3, 3, x to the 0. Negative 1 times 7, negative 7, x to the negative 2. What do we have here? 3x squared. Remember, x to the 0 is 1. And then look, the 7 doesn't have a negative exponent. It stays. Just the x has the negative exponent. And that's all you have to do for that one, okay? You can leave it for now. That's your answer, okay? Wonderful. Same exact story. Whoa, I could never in my entire life take the derivative of a quotient. I need to come up with single terms. How in the world do I do that? Oh, there's a monomial in the denominator. Now that there's a monomial in the denominator, I can do what I'm doing here. Now, this is going to be x to the third. This is going to be 4 over 2 is 2. That's going to be x to the 4th, and this is going to be 3 over 2x to the 5th. Okay, so I'm still rewriting it. Notice how I never put g prime of x yet. So g prime of x, not yet. 5 halves, leave the 2 in the denominator. 5 halves, x to the negative 3. Leave, well, there's nothing there. X to the negative 4. Leave the 3 halves, x to the negative 5th. Now it looks like I can do the power rule. So, reader, g prime of x. So we got 5 halves times negative 3. So that's going to be negative 15 over 2, x to the negative 4. Then I have negative 8, x to the negative 5. Then I have negative 15 halves, x to the negative 6. And then if you want to put it in the denominator, you're more than welcome to. But the only thing you're putting in the denominator is this, this, and this. This goes next to the 2. Those two go next to the 2 in the beginning and the end. So I hope that makes sense, okay? So know your algebra. Let's see what else we have here. Ready? Yes. All right, we have f prime of x equals 2x to the first. Negative 3 times negative 1 is positive 3. X to the negative 4. That's all I have to do there. And that's pretty much it. How do we multiply fraction? Top times top, bottom times bottom. So 4 times 7, 28. 5 times 4, 20. How do I subtract? Do you remember from the last video? 7 minus 4 is 3 over the denominator. Okay, here we go. 1/9 times 2/3. 2 times 1 is 2. 3 times 9 is 27. How do I subtract? What's 1 minus 9? Negative 8 over 9. Okay, so that's what you do there. I'm going to just help you here for a bit. 28. 20, denominator on the outside, okay, plus 2 27ths, denominator, that's not a negative exponent. I know it, I'm going to get the comments. X to the 3/4. and that this has a negative exponent, so I'm putting that on the bottom with x to the 8th because denominators on the outside, numerators on the inside, okay? This one does not have a negative exponent. Be careful. Final problem, I think so. 3 times 4, 12. 9 times 2, 18. X to the 4 minus 9 is negative 5 ninths. 1/4 times negative 1/3 is negative 1/12. Negative 3/4. Remember what I'm doing to the exponent. I'm constantly subtracting 1 from the exponent. Think about it. You have a quarter and you owe me $1. So that means you're still gonna owe me 3/4. So that's what I do there. Now, because the negative exponents, you can clean them up, okay? 12 over 18, both have 6 in common and blah, blah, blah. All right, so that's how we do the power rule. What is the derivative of f of x equals sine x? F prime of x equals, come back. F of x equals cosine x. F prime of x says, and watch the next video. So if you guys want to see the derivative of sine x and cosine x, I'll be making that in my proof playlist. And then we are going to start using it. And this stuff is going to become beautiful. So come back.